Hi guys, sorry I couldn't be here today, but I figured this was an easy lesson for you guys to learn through a video, so here we are. This is Chapter 3, Section 3. It's titled Function, Operations, and Compositions. So there's two different things that I want you to learn today. Operations and then separately compositions. Operations, anytime you see that word, all it's talking about is the addition, subtraction, multiplication, division. Easy peasy stuff. So because we're dealing with functions, we have two functions here. I'm going to give you f of x equals 5x minus 4, g of x equals x squared minus 1. Remember, f of x is just another fancy way to say y equals, but so is g of x. G of x is also y equals, but we're basically trying to be more specific about our equations now. So we're basically saying this equation is equation f, this is equation g. So then we don't have to keep referring to everything as y equals, because that would get confusing if I had multiple. So if we're trying to add our functions together, all you're doing is taking f of x, adding it to g of x. So you're just plugging in f of x, we said, was equal to 5x minus 4, and we're adding that to our g of x, which was x squared minus 1. Since we're adding, we're just combining like terms. This is stuff you guys know how to do. We're always going to write stuff in standard form, though, as much as possible. So the only like terms I think we have to combine is that minus 4 and the minus 1. So that would just make it x squared plus 5x minus 5. And then we're done. Subtraction is similar. The only thing with subtraction is you guys have to remember to distribute your negative. I still see you guys kind of messing that up sometimes. So make sure anytime you see the subtraction sign there, you are distributing the negative to both those terms. So rewriting this while distributing the negative, we get 5x minus 4 minus x squared plus 1. So this time, combining like terms, we have a negative x squared plus 5x minus 3 because of that negative 4 and plus 1. So that's it for subtraction. Multiplication means we're multiplying our two functions together, which really means we're foiling. So we have that 5x minus 4 times x squared minus 1. Foil everything out. I think you end up with 5x cubed minus 4x squared minus 5x plus 4 as your final answer. Division is just as simple. Let's say we're trying to divide f of x divided by g of x. So we would write it out like that, 5x minus 4 divided by x squared minus 1. So here, we do have to try to simplify this as much as possible. And by simplify, I mean factor if you can. So 5x minus 4 doesn't factor anymore because it doesn't have an x squared in it. But the x squared minus 1 does. And those are a difference of squares. So we know it's going to factor into x plus 1, x minus 1. 5x minus 4 stays on top. We want to see if there's anything on the top and bottom that can cancel by being exactly the same. So on the bottom I have x minus 1, x plus 1. Obviously does not match the top, so nothing cancels. This is as simple as possible. However, do you remember that one rule about not dividing by 0? Like you're just not allowed to. If you ask Siri, it'll tell you something about splitting 0 cookies between 0 friends and something about you don't have any friends. That's a fun one to ask Siri. So ask Siri 0 divided by 0 for funsies if you would like. But you're not allowed to divide by 0. That is the rule. So because we have variables on the bottom, we don't know what x equals because nobody ever told us. So we kind of have to tell people, hey, make sure you don't plug anything in for x that makes the bottom equal to 0. So I want to know what can I plug in to the bottom that would make this multiply out to 0 so that I can tell people, hey, x cannot equal, and my two numbers are going to be 1 and negative 1. Because if I had plugged in 1 into this x right here, I will end up with 1 minus 1, which is 0. That's bad, because 0 times anything is still 0. I also can't have x equal negative 1 because if I plugged it into this parentheses, then I'll end up with 0 over here. And again, 0 times anything is still 0. So I have to tell people this is what x cannot be. Make sure you don't use those numbers. So anytime you divide, you have to do that last step where you figure out what x can't equal based on the denominator. So that's it for function operations. So compositions is the next thing that I want to talk about. Compositions of functions. Compositions of functions just means we're plugging stuff in. So I'm going to use the same f of x and g of x as before. But compositions would be something like if I had asked you to find f of -2. So I don't know if you've seen this before. I just want to see if you remember, make sure you remember. Whatever's inside the parentheses, that just means in the f equation, plug in -2. So here's my f equation. I'm going to plug in -2 wherever I see x. So that means I'm taking the 5 instead of writing x. I'm writing -2 minus 4. So I'm just plugging it in. I end up with -4 or -10 minus 4 gives me -14. So f of -2 equals -14. I can do the same thing with g of x if I said g of -3. This means in the g equation, plug in -3 whenever you see x. So this would end up being, if my g equation is x squared minus 1, instead of x, I'm going to write a -3, square it, minus 1, which gives me, remember, -3 squared is a positive 9, minus 1 gives me 8. So g of -3 equals 8. Okay, I'm going to make it slightly more complicated now. Okay, lots of parentheses here. So what this means is f of g of -3. Remember, with the parentheses, we just read it as of. So according to PEMDAS, we always start with the very inside of our parentheses. Parentheses always comes first. The stuff that's on the very inside of our parentheses is right here, g of -3. G of -3 is just that number that we just found. G of -3, we did that already. So you're just taking -3 and plugging it into the g equation. So when we did that, we got 8. So I'm going to replace this part right here with an 8. Because now this means take the f equation, plug in 8 wherever you see x. So that'll give me 5 times 8 minus 4, which is 36. So f of g of -3 equals 36. I can write it the other way as well. Let's say I'm trying to find g of f of g of f of 1. We start on the inside, so find f of 1 first. F of 1 means take the f equation, plug in 1. So I'm going to write this underneath. F of 1 equals 5 times 1 minus 4, because 5x minus 4 was my f equation. I end up with 1 from that, because 5 minus 4 is 1. So that means now I'm really finding, if I replace the f of 1 with the number 1, now I'm just looking for g of 1, which means plug in a 1 wherever you see x in the g equation, which was x squared minus 1. So 1 squared minus 1 using the g of x equation would give me 0. Okay. These next ones are even more complicated. So this time, rather than giving you a number to plug in, I'm going to leave this as g of x. So I'm trying to find f of g of x. So again, we start with the very middle of our parentheses, so g of x. They're not asking us to plug anything in, it's just left as x, which means they already told us g of x equals x squared minus 1. So I'm going to rewrite this as f parentheses x squared minus 1, because all I've done is replace that g of x with what it equaled, which was x squared minus 1. So now this is saying take the f equation, plug in x squared minus 1 wherever you see x. Okay, so our f equation was 5x minus 4. So 5, instead of writing x, I'm going to write all this stuff inside the parentheses. And then that minus 4 at the end. Simplifying this down, I'm going to distribute the 5. And then I have that minus 4 at the end. So this ends up being 5x squared minus 9. All right, let's do another example. Again, I'm going to keep using the same equations. This time I'm going to do f of x. It looks funny because you got two f's. However, so we always start on the inside. We're just replacing the f of x with what f of x equals. Earlier we said f of x was equal to 5x minus 4. So I'm just going to substitute that 5x minus 4 instead of f of x. So now this means in the f equation, take this and plug it in, substitute it in wherever you see x. So my f equation originally said 5x minus 4. So this time, instead of writing x, I'm going to write 5x minus 4. Once I have that plugged in, simplify it down again. So distribute your 5, subtract 4 at the end, will give me 25x minus 24. All right, one more example. Make it slightly more complicated now, just because of the way the order is. So still doing the same stuff as before, just g of f of x. So we start with the inside of the parentheses, which is f of x. So I'm going to replace f of x with what f of x equals, which was 5x minus 4. So now this says, in the g equation, plug in 5x minus 4 wherever you see x. So the g equation originally said x squared minus 1. Something squared minus 1. Instead of writing x, though, we're going to write in the 5x minus 4. This is only more complicated because now you have to FOIL this out. I know how much you love foiling. So you end up with 25x squared minus 20x plus 16 minus 1. Simplifying this more, combining like terms, you end up with 25x squared minus 40x plus 15. And that's it. That's function composition. Done. Thanks for watching this video. Good luck on your homework.